This is Applications and Modeling with Linear Equations 1.2. So this is pretty much everyone's least favorite section of the entire course. So I'm warning you with that because 1.2 is all word problems. Okay, yes, all word problems all the time. So again, that's why it's everyone's favorite. But it's my job, and hopefully I can make it easier for you. We're only going to look at a couple of different types, so hopefully that'll also narrow it down for us or help in how we solve these things. So here is just kind of how we're going to do it, laying the groundwork, so to speak, and then we're going to just work through examples. Example. So it's always nice when a formula exists that we can make use of to solve a particular problem. However, in many instances, we must build our own formula or equation based on the information available in the problem, solving our equation, then solving the problem. So here's the strategies. 1. Read the problem carefully, determine what the problem is asking for, and assign variables of unknown quantities. Make an appropriate figure or table if applicable. Label the given information and variables in the figure or table. 3. Write an equation that represents the verbal model. The equation may be a known formula or one that you create that is unique to the problem. 4. Solve the equation from step 3. And then 5. Interpret the solution to the equation and check that it is reasonable in the context of the problem. So, sometimes you can kind of skip like 2. If you need to for 3, sometimes a formula really does exist. It just really depends. So, example 1. The cost for a company to produce computer boards is $50 per board, in addition to a $50,000 startup cost. If the company is planning to sell the boards for $75 each, then how many boards does the company need to sell to break even? All right, so first, we need to talk about what it means to break even, right? So in this case, to break even means that we don't have any overhead, right? We don't have any costs. We also don't have any profit or revenue. Basically, no profit, right? So here, to break even means that our cost is equal to our revenue, right? So cost is equal to revenue. So, because that means, right, it didn't cost us anything, but we also didn't make anything either. Remember, just for a side note, profit is equal to the revenue minus the cost, right? So hopefully if we have profit, we have a lower amount of cost than we do revenue. Oh, some people ask, what the heck is revenue? Revenue, I think of as the money in your cash register at the end of the day, basically, right? So how much is in the register at the end of the day? So we need 2 equations here. We need a cost equation and a revenue equation. So first, so that means we've got to go through the word problem. I like to go through it really line by line, sentence by sentence. It just helps me kind of collect all the information. So cost. So for my cost equation, typically a cost equation is a linear equation in the form of mx plus b, where m is what it cost us per item, right? X is equal to the number of boards. Okay, in this situation, X is the number of boards. So like it says, cost to us $50 per board. So for our cost of equation, that's $50 per board. And then in addition, so literally plus $50,000 worth of startup cost, right? It's in the name, cost. What is a startup cost? Startup cost could be rent for the building, any machinery that you have to buy, right? If you've got to buy, not welding equipment. What's it called? Soldering equipment. Yeah. You have to do hiring paperwork, maybe that kind of stuff. Just startup costs. Everything you need to collect before you even start your business. And then revenue. So revenue, right, is the money you take in. So if I'm planning to sell the boards for $75 each, right? Well, then that means that if I'm selling it for $75 each, in my register is $75 times the number of boards that I sell that day. So revenue is equal to 75x. So now, in order to break even, we set these two equations equal to each other and solve. So I've got 50x plus 50,000 equals 75x. So learning from what we talked about in 1.1, we need to combine like terms. So I'm going to subtract the 50,000 over, or excuse me, subtract the 50x over, rather. So that gives us 25x. Now to solve means we get x equals, so we are going to divide the 25 into the 50,000, which is 2,000. So in order to break even, we have to create and sell 2,000 boards. All right, what do y'all think about that one? This, honestly, example 1 and example 2 are probably the easiest ones that we are going to talk about. Well, example 4 on the next page is also not too bad. So example 2. So in a jury pool, this is also what we call a ratio. A ratio or proportion example. This is kind of just like a cost of business example. This example, if you are a business major, you have to take, what's it called? Well, Business Calculus 1329. This is going to be your bread and butter, cost, revenue, and profit. Those are 3 equations that you're going to have to know, or actually you're just going to know by the end of the class. So back to example 2. This is a ratio or proportion example because in math, like I've said already, they call it like they see it. You're going to, what's it labeled is either what it locates, what it defines, or what it does. So here, this is more or less how you solve, right? So the method. So in a jury pool, there are 8 more men than women. If the ratio of men, hint, why it's that example, if the ratio of men to women is 8 to 7, determine the number of men and women in the pool. All right, so again, I go line by line. Line by line. There are 8 more men than women. So if there are 8 more men, that means men is going to equal W plus 8. Again, well, M is men and W is women. So if there's more men, that means it's W plus 8. The ratio of men to women is 8 to 7. So men to women is equal to 8 to 7. But combining these 2 statements here, right? Do we know what M equals? Yeah. So combining those 2 things, we get that W plus 8 over W equals 8 over 7. Right, so now we can cross multiply so that 8W equals 7 times W plus 8. Distribute the 7 to help us solve. So 8W equals 7W plus 56. Combining like terms, so to combine the W's, I'm going to subtract the 7W over. So W equals 56. So there are 56 women. But are we done? No, because we need to know how many men and women are in the pool. So now, combining these 2 things, men is equal to women plus 8. So we know that there are 56 women plus the 8 more men. Then I know that there are 64 men. There you go. Again, if you have any questions on any of this, my email is ld1168. Right? Shoot me an email. Let's set up a Zoom account. We will get you all squared away.